All right, guys, let's go ahead. Let's do another related rates problem. This one's pretty straightforward, so it shouldn't be too bad. A pebble is dropped into a calm pond, causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area of the disturbed water changing? Okay, so a little background knowledge before we get anything done here is what is the area of a circle? Do you guys remember the formula? Well, oh gosh, that's huge. It's right here. Okay, area of the circle is A. Hopefully you guys remember that. We haven't really gone over too much circle this semester. So, oh yeah, we did actually in the beginning of the semester. So maybe that's fresh in your mind. Okay, so there's a couple things to note. Here they say radius is increasing at a constant rate of 1 foot per second. Okay, that means the radius changes as time goes on. So maybe I'll draw a little picture. Boom, 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 boom. What is our radius? I guess I gotta make everything a little smaller. At time 0, the pebble just got dropped in. So the radius is 0. Okay. Okay, so what about at time 1? Okay. Every passing second, the radius increases by 1 foot. So this is what our circle looks like now. And the radius, boom, has now a length of 1. Okay, so how about, come on, how about when the radius of my circle has now increased yet again. Every passing second, 1 foot, the radius is increased by 1 foot. So now the radius is 4 feet. So the question is, yes, we see that the radius is increasing with time, but also notice that, wow, I don't, oh God, bum. Notice how the area of the circle is also changing with time. So in that first instance where t equals 0, the area is also 0. But if we come over here, the area of the circle has increased. And if we come over here, again, the area has increased yet again, right? The area of the circle. So the question is, at this point right here, when the radius is 4, at what rate is the area growing? That's the question here. So the first thing we want to write, or the first thing we want to change is this. A equals pi times r squared. We should rewrite that because r right now is written in its nickname. We should write r as its true name. Function of time. The radius grows as time passes by. So we should write it like this. R is a function, right? And we know this from these pictures right here, right? We said that my radius is 0. My radius is 1 foot. 1 seconds pass. Okay. And the area then, A of t, has probably a shape like this. When t is 0, the area here is 0. When at time 1, what is my area? Well, area equals pi r, but when t is 1, r of t is also 1. So when t is 1, r of t is also 1. It's just pi. Okay. And the same thing at t equals 4. It's going to be a bad picture, of course. You know how we do here. When t equals 4, we have, well, what is r of 4? Well, r of 4 is when t equals 4. What is our r of t equal? It's also 4, so we have 4 squared. So we have the area equals 16 pi. So maybe 16 pi is up here. It should be higher, a lot higher. So this curve will look something like this. And the question that they're asking us is, how fast is the area changing with respect to time? So how fast is the area changing with respect to time when the radius is 4 feet? Well, when the radius is 4 feet, time is 4. So we're looking at time 4 here. And we're trying to find what the rate of change is at this time. That means we're trying to find the tangent, the slope of this tangent line right here. dA dt for this point, how do I write this? What's the best way to visualize this for you guys? Like this? I'll just say it. So I'm looking at maybe like this. This will make sense, right? Because I plugged in 4 here. So I'm trying to find the rate of change when t equals 4. So what is the slope of this tangent line? That's what the question is asking. Okay. When the radius is 4, at what rate is the total area changing? So when the radius is 4, we know it's at time 4. Therefore, when we have time 4 at the base here, we have 16 pi for the area. But what they're asking for is not what the value is of the area. We're not asked how large the area is at that time. We're trying to figure out the rate of change, which is the slope of this tangent. Okay, so let's go ahead. Let's finish this question up. So they want us to find dA dt. So let's take the derivative of both sides. So d dt of A equals d dt of pi r t squared. Okay. So dA dt is just dA dt. And see, if you have a constant here, you can pull it out in front. If you're multiplying by a constant, that is, you can pull it out in front of the d dt of r t squared. And anytime you do these problems, you're going to have to use implicit differentiation. So don't forget the rule for implicit differentiation. dA dt equals pi times. So I drop the exponent. I keep the inside function the same. So this guy just stays the same. And I take 1 away from the exponent. Then I multiply this whole thing by the derivative of the inside. But the derivative of the inside is just the slope of this line right here, right? And they actually give it to us in the question. They say that the slope of this line is 1 foot per second. So the slope is just 1 times 1. Maybe before we even fill it in, I'll just say dr dt, just so you guys can see the implicit differentiation. So let's simplify this. We have pi times 2 times r of t times dr dt. And now our goal is just to fill in these blanks, okay? So the first question is, what is t? Well, we already said what t was. Because the question is saying, when the radius is 4, we know that when the radius is 4, t has to be 4. So this sentence is actually saying times r of 4 times dr of 4 dt. So we get r of 4 is just 4, and the rate of change is the slope of this line, which was given in the problem, which is just 1. So it's 8 pi. And there we go. That's our answer. So our answer is that the area is increasing by 8 pi square feet per second. So I know when you do this on a test or something, you don't have to do all of this extra garbage that I did. You can simply do the algebra and the calculus. However, if you miss the concept behind this, you might get the question wrong. That's why, like, when I do these problems, I draw everything out. If you can visualize math, you'll be better off. And if you could draw it out, that's even better. All right, guys, I'll see you in the next one.